Hi, I'm Lily and this is Olivia, and we're both graduate students at Dartmouth College studying earth sciences. Today we're here in California with Dr. Meredith Kelly looking at landforms left behind by glaciers during the last glacial maximum.
The cool thing is, like Meredith said in episode 1, back at school in New Hampshire, we're also surrounded by glacial landforms.
Using observations and measurements to figure out how landforms were deposited is a field called geomorphology.
Today, we're going to make measurements and observations of two landforms, ridges and plains. These observations of the ridges and plains will allow us to figure out what the environment and climate were like thousands of years ago in the northeastern United States.
Let's get out your field notebooks and make some observations and measurements. If you need more time, feel free to pause the video at any point during this virtual field trip. With that, let's turn it back to Meredith, who's going to take us up, down, and around a ridge.
So I'm walking here in Pine Park, a local park in Hanover, New Hampshire, located about a mile north of my office on the Dartmouth College campus. And this is a pretty incredible place. It's a wonderful place to take a walk on a shady path on a hot day in the summer. It's also a really incredible place to take a look at something called geomorphology, which is essentially a study of the earth and the shape of the landforms and the sediments that make up landforms on earth for the purpose of understanding how those landforms formed, what environments they register, and the processes that went into creating them. So this is a study called geomorphology, and it's essentially the question that we're asking here. What can measurements and observations of the surrounding landscape tell us about past environments? Okay, so we are here on the Hanover Golf Course, and we're going to go up, walk up and check out this ridge or hill. For scale, you can see the dog Bailey in front here, and that little pink girl running towards us is my daughter Lila, who's going to be joining us for the rest of the field trip. Okay, so we are now on top of the hill or the ridge that we've been looking across the golf course at. And there is a view of my daughter running towards the south. And what I just want you to observe here is that there's a significant amount of elevation drop from the top of this hill. There's some sort of humpy, lumpy features on the side of the hill. So right now we're looking here towards the east. And I just want to scan down and show you what the shape of this hill looks like on this side. And then give you a chance to get a perspective. Okay, so we're walking here along the hill or ridge that we've already viewed from the Hanover Golf Course. Now we're actually on top of that ridge, and we're in a forest along a path, a really nice path that runs right along the top of the ridge. And it's here where I can really show you why I'm calling this a ridge. So we're walking pretty much due south here, and to the right of me, to the west, you can see there's a really steep drop off. And that side of the hill here is very steep. Well, if you look off to the left of me, also to the east, that side of the hill is also really steep. And that's why I would call this landform a ridge. And the surface here is actually really beautiful and flat, and makes for a really nice walking path.
Welcome back. Hopefully you got some good notes describing the general features of the ridge.
Next, we're going to make some measurements to determine exactly how high above the river the ridge is.
Here is an aerial view of the ridge taken from Google Maps. We'll draw a red circle around the ridge, and then we'll substitute in a LiDAR image to strip away the trees.
The LiDAR image makes it a lot easier to see the actual ridge. The line down the center of the ridge shows the trail where Meredith was walking.
To get an accurate measurement of how high the ridge is, we'll need to use a topographic map. Topographic maps allow us to compare the elevations of different parts of the map area. Here is the topographic map of our ridge.
The brown lines on a topographic map are called contour lines. These contour lines trace points of the same elevation. The extra dark contour lines are called index contour lines. I'll trace the 400 and 500 foot index contour lines.
This map shows 100 feet of elevation change between the dark index contours. By then counting the brown lines between those darker index contours, you can determine how much elevation is represented by each line.
Our goal is to measure how high the ridge is above the Connecticut River. We'll zoom in and add a dashed line exactly where we want to measure.
Go ahead and determine the change in elevation between the river and the top of the ridge. Write it down in your notebooks, compare it with your classmates, and feel free to pause if you need some more time.
Welcome back! By now, hopefully you all have some good notes on the external features of the ridge. Now we're going to join Meredith and dig into the ridge to see what's going on underneath the surface.
So we're in Growbrook Valley in Pine Park here, and we've walked down to find this exposure, what I call outcrop, into the sediments that make up the valley walls on the sides of the brook here. The brook has done this incredible job of eroding down into the valley, exposing these sediments. And the sediments that we're looking at here make up the ridge or the hill that we were looking at on the Hanover Golf Course. What we want to start thinking about is how to describe these sediments. And we'll think about that a little bit more using the still image and the detailed up-close image of the sediments.
Okay, let's get those notebooks ready so we can make some observations about the material in this outcrop. We'll also show you some up-close photos so you can make better measurements and observations.
The first thing we're going to ask you to do is observe the size of the particles. Super small particles are called clay, silt, or mud. Slightly larger particles are called sand. Even larger particles are called gravel or pebbles.
The second thing we need to figure out is the sorting. You need to decide if your particles are all the same size or if they're a bunch of different sizes.
The third thing we'll need to decide is if the material has layers or if it's random with no visible layering.
The fourth thing you need to observe is the shape of the particles. You need to decide if your particles are smooth and rounded, which indicates transport by water, or sharp and jagged.
The last thing we'll have you record in your notebook is a sketch. A good scientific sketch should always include measurements. We'll put a tape measure into the image so you can be as accurate as possible.
That's a lot to do. Go ahead and pause the video so you can jot down your observations. Compare with your classmates, and when you're ready, hit play so we can keep on rolling.
Welcome back! Hopefully by now you all have some good observations and measurements in your notebook. Right now, go ahead and make a header in your notebook called Geomorphology Interpretations. You'll fill this section in when Meredith comes back.
Let's move on to the second landform left behind by the ice sheet, geologic plains. Today we're going to look at two geologic plains on the Dartmouth campus. One that's in the center of campus and the other that's on a golf course just a little bit north of us. Here's a Google Earth image of the golf course.
We can start by making some external observations and measurements like we did at the ridge. Here's Meredith to take us on a walk around one or two of the plains.
Okay, we're here now on the Dartmouth, or what's called the Hanover Green. It's a big, green, relatively flat area, actually very flat area. And my daughter's here doing gymnastics. It's a really popular location. People sit out here and have picnics, they play frisbee, they play football. It sits in the middle of pretty much the main part of campus, so students cross here every day to go between classes. And I want you to take a look at this with a different perspective, with the perspective of a geomorphologist. So we want to think about this as, what kind of landform is it? And that might seem like a weird question, because this area might seem developed and perhaps even really modified by the college, but in fact it's not. And these very flat surfaces occur all along the edges of the Connecticut River Valley, between Hanover, north of us, and then even to the south, as far south as into Connecticut. And we're going to be able, in a couple minutes, to take a look at the sediments that actually underlie this landform.
Hopefully you got some good notes describing what a plain looks like. Now we're going to pull out a topographic map to measure the change in elevation across the golf course.
Here's a Google Earth view of the plain again. We're going to calculate the elevation change across the plain along this dotted line, starting from the golf course and going to the soccer fields.
Let's substitute in a topographic map of the area so that you can measure the change in elevation. Go ahead and measure the elevation change along the red line.
Pause the video and compare answers with your classmates. When you're ready to continue, hit play and we'll go ahead and make some internal observations.
Welcome back. Now let's set up your notebook to make some internal observations like we did on the ridge. Remember that you'll need to measure size, sorting, layering, and make a sketch.
Go ahead and pause the video while you get your notebook ready. When you're ready, hit play and Meredith will come back to help us with some interpretations.
So how do we learn about what makes up these landforms that are the flat surfaces? Well, we can look for places where there are exposures underneath the flat surfaces. Now I've included a couple images of these. One of them is from actually on Dartmouth campus itself, where you can see excavations into buildings that were being built. There's one where you see a professor, James Goldthwait, at Dartmouth in the 1930s, looking at a new excavation into a building, and you can see the sediments below that. There's also another photo that I took more recently while Dartmouth was working on the pipes that traverse the sediment below campus for the heating of Dartmouth campus. In both of these, we'll come back and we'll make some observations about these sediments. We're standing here in the Girl Brook Valley, and this valley, the brook itself, has done an incredible amount of work to expose the sediments that underlie the golf course and the Dartmouth College campus by down cutting. So the stream has actually cut down into the landscape itself, flowing down to the Connecticut River, and exposed these sediments. And what you see here is a beautiful outcrop of these sediments. I'll walk up a little closer here. So we have some detailed still images of these sediments that I'm going to call varves. And the first thing I'd like you to do is describe what these sediments are. What are their grain sizes? You can use the terms small, medium, large. Geologists like to call grain sizes by names that are clay for very small grain sizes, silt a little bit bigger, sand and gravel for the biggest grain sizes. What's the sorting of these sediments? And that means, are there all one size sediments, or are there more than one size to these sediments? And are there any structures to these sediments? And by that I mean, are there any layers to the sediments? And I think you can start to see that here and also in the still imagery.
Welcome back, and nicely done. Let's make some space in your notebook to write down Meredith's interpretations of the plain.
We'll bring Meredith back now and see how she uses all of these observations and measurements to understand what the climate and environment were like thousands of years ago as the last ice age ended.
Okay, so this is Meredith again, and we are back here to where we started, which is on the Hanover Golf Course. And I want to try to wrap some things up here. So we've seen a lot, and you have started to make some measurements and some observations. And so I want to take those observations and make some interpretations based on them. So we've looked at two main landforms, the ridge and the plain. And in the ridge, let's start with that one. So the ridge, you can see out here actually to my left, to the west, and we noticed that it was a ridge. You made measurements about how high elevation or high relief that ridge is. And then we looked at the sediments and we saw that they are this coarse grain, this larger grains. They were sand and gravel, and that gravel was rounded and there weren't any layers in it. And from this, as a geologist, the way that I would interpret this is that this sediment had to have been transported by pretty fast moving water. And the environment that I think of when I think of fast moving water is some kind of really high powered stream. Okay, so this is the way that we'll interpret that, and you may be scratching your head a little bit and thinking, that's weird. Why would a stream, which you usually think of as forming in a channel, actually take the form of a ridge? And that's curious, and you should be thinking, that's a little weird. I don't believe her. But come back in episode 3 and we'll work through that and talk through that and think about how a stream, particularly a very fast flowing stream, might take the form of a ridge. Okay, so the second feature that we've looked at is what we've been calling a plain. We saw that on the Dartmouth green. We also you measured that on the topographic map in a place on the golf course, and I hope that what your observation showed is that the landform itself is very, very flat, and the sediments that we looked at in this landform are very small in size. They're mostly silt, clay, which together make up mud, and there really is no larger grains in there. And then they have this cool structure. They're layered. They have thin layers throughout the deposit that we looked at. And the way that we're going to interpret these, and the way that I see these as a geologist, is to get very, very small sediments deposited. In many ways, you have to have a quiet environment where those sediments can either settle out of wind or water. They're also pretty well sorted. There are no larger grain sizes in there, sediment sizes in there. And a couple of the best environments to do that are out in a deep ocean and also in a lake. And that's in fact how we're going to interpret this landform here, is the very flat surface, and the small sediments that make it up are the bottom of a lake. So those small sediments settled out in the water in the lake, and we're able to form a very, very flat surface that we'll call a lake bed. So together, our observations show that in a time in the past, Hanover had very flat, fast-flowing stream and lake. So these are obviously not here right now, and the sediments are not yet made into rock, so that tells us they're pretty recent. And in the recent geologic history of Hanover, one of the biggest events is that there was this large ice sheet that covered the area. Again, we talked about this at episode 1. It covered most of northern North America, and as the climate warmed at the end of the last ice age, this ice sheet started to melt and recede, and as it receded through this area, it had a lot of water associated with it. So in episode 3, we're going to tie the fast-flowing stream and the lake into the recession, or the melting, of this large ice sheet through this area, and we're going to figure out how we can use these landforms to understand how we can look at how and how fast ice sheets retreat through an area, and that this is important for understanding how ice sheets are retreating today. Okay, I'll see you in episode 3. And they have this really cool structure. Hold on one second, yes?
Are we going to go to the same place where I ran around and did cartwheels?
We can if you want.
I want to. I want to go to the circus.
Okay, GoPro stopper.
So funny.
Tough one.
So, it
Showbiz.
is a tough
No
one.
joke.
Showbiz.